to continue on our lecture, okay, so the main focus actually of this chapter is basically using the Anova approach, okay, analysis of variance approach by means of testing the mean. Okay, even though the name is still, if you look at the title, okay, is Anova, okay, analysis of variance, but when it comes to testing 3 or more populations, okay, because in chapter 9 we learn on how to do a hypothesis testing when you are comparing 2 populations, group A and group B, okay, sample A and sample B. Okay, but if you are comparing more than 2 populations, 3 populations, 4 populations, then we need another approach or another model to be able to do hypothesis testing. So this is when the F distribution will be very useful. Okay, so the characteristics or the assumption is similar to your 1 sample or 2 sample test in chapter 8 and 9. Okay, the population should follow normal distribution, and then okay. So the first part is, of course, how you do the hypothesis testing. So we start from as usual, step number 1, okay, constructing the H0 and also the H1. So if you notice from the H0 here, okay, one thing easy about whenever you do hypothesis testing with the F distribution with Anova, okay, whenever you are comparing 3 or more population, the H0 and H1 are exactly the same for all questions or for all scenario. Okay, let's say you are comparing 3 populations, so it will be mu1 equals to mu2, okay, and then equals to mu3. Okay, so let's say we are comparing 3 populations. So the way you construct your H0 will be just mu1 equals to mu2 equals to mu3, and H1 you always write this way. Okay, the means are not all equal. Okay, so actually this part is not needed in when you want to construct your H0 and your H1. Okay, if you are, so in this case we are comparing 3 population. If you are comparing 4 populations, so just add another mu value here. So let's say mu4 lah. Okay, so but the H1 is always the same. You only write the means are not all equal, regardless of what questions that you do. Okay, because when it comes to Anova testing, whenever you are comparing 3 or more populations, more than 2 populations, okay, there is no one-tailed test. There is no one-tailed test on the right. There is no one-tailed test on the left, or there is, so every test that you do basically is all based on the same hypothesis for H1. The means are not all equal. In other words, I'm not saying, so we cannot say that this is like a two-tailed test, okay? Because two-tailed test means you are only comparing 2 populations, mu1 not equals to mu2. Okay? But when you put H1, the means are not all equal. So let's say you have 3 mu1, mu2, and mu3. So what it means by not all equal, you may get mu1 equals to mu3, but mu2 may not be equal to mu3. So this is what this means. Are not all equal means maybe some of the mu is equal, but some is not equal to the other one. So it could be mu1 equals to mu2, but not equal to mu3. Okay, so that's why we cannot say that this is like a two-tailed test. So whenever you do a whenever you write your H1, just follow this. Just write this simple sentence here. The means are not all equal. By meaning that, okay, if you have 3 populations, maybe mu2 is equal to mu3, but not equals to mu1. Or it can also be every mu1 is not equal to mu3, mu2, and also not equal to mu3. But because we do not know what is the exact equation, so we just put this way: the means are not all equal. Okay, because it could be all not equal, or it could be just one not equal. Okay, so this is how actually you write your H0 and your H1 for Anova testing. Okay, and then the rest for the 5 steps procedure. Okay, first you define your H0 and your H1. Okay, and then you conduct and then you perform the hypothesis testing based on the following steps. So step number 2, determine what is the level of significance which will be given to you. And then what test you want to use? You are going to use the F test, step number 3. Step number 4, determine your critical value or your decision rule. Reject H null when F is more than what value. Okay, so whenever you are doing ANOVA testing, okay, if you go back to this part here, okay, reject H null if computed F is greater than critical F. So basically, this part is similar to step number 4. Okay, if you recall from step number 4 in your, let's say if you go back to this slide here. Okay, step number 4, whether you are doing 1 sample test, 2 sample tests, chapter 7 and chapter 8, chapter 9. Okay, in step number 4, this is what you want to write. You want to write your decision rule. If you are using Z, then this will be Z lah. If you are doing T, then this will be T. Okay, if it is 1 tail test on the right, it will be more than. If it is 1 tail on the left, this will be less than. If it is a 2 tail test, then you're going to be 1 is more than, and another sentence will be computed Z or T will be less than. Okay, but either way, okay, step number 4 is always about stating the decision rule. Reject H null when calculated value of Z or T or F is bigger than what critical value. So in this case, the critical value is 3.87 for this particular example. So what you see here in this part here, okay, basically this should belong in step number 4. So when you are writing your answer for topic like this, okay, so when you are, because whenever you are doing hypothesis testing, you must present your answer according to the 5 steps. Step number 1, step number 2, step number 3, until you arrive at step number 5. So step number 1 is your H null and your H1. Okay. Step number 2, as usual, what will be the significance level given from the question. Step number 3 is the same as this one. The test statistics is the F distribution. Okay. But then step number 4. Okay. So what you learned last week, okay, when we do when we apply this the test for variance, okay, you are going to follow the same step. Okay, reject H null if computed F is greater than what value. Okay, because whenever you are doing hypothesis testing for ANOVA or for F distribution, this sign will always be more than. Okay, there is no not equal to, there is no less than. So the sign for this step number 4 is always more than. Let me change the color. Okay, it's always more than. Okay, so the sign here is always more than. So you cannot write less than. There is no sign of not equals to. Okay, so there is no such thing as reject H null if computed S is less than, or there is no such thing as reject H null if computed F not equal to. Because whenever you are doing, whenever you are using the F table, the sign for the step number 4 is always greater than. So computed F is more than what value. So in this, so whenever you are comparing more than 3 or more populations, okay, so if you notice this, the DF, K minus 1 and N minus K, why is this different compared to the previous one that you just saw last week? Okay, so how do we know this is 6, this is 7? Okay, the sample size from this is 7 and 8. So 7 minus 1, you get 6. 8 minus 1, you get 7. So N minus 1 and N minus 1. So that's how you determine the degrees of freedom for the numerator to be 6 and the denominator to be 7. So in other words, when you are doing this testing for the variance, the degree of freedom for the numerator and the denominator is based on N minus 1 and also N minus 1. But this is not the case when you are doing the F distribution for more than 2 populations. Why? Because the DF now becomes K minus 1 for the numerator, and for the denominator becomes N minus K. So what is K, what is N? So N is always the sample size. So what is K? So we're going to explain that in the next few slides. But you need to make sure that whenever you are referring to the F table, if you are testing 2 or more population, okay, in other words, if you are doing something like this, okay, so whenever you refer to the F table, the numerator degrees of freedom will be k minus 1, not n minus 1, and the denominator will be n minus k, not n minus 1 also. Okay, so what is k minus 1? If there are k populations being sampled, the numerator will be k minus 1. So k basically is how many groups or how many populations. So for example, in this, so let's say if we are doing 3 populations, mu1, mu2, and mu3, meaning there are 3 populations, population number 1, population 2, population 3. So 3 populations mean k will be 3 lah. So this will be 3. Okay, so k basically how many population that you are testing, how many groups. Okay, so in this, if I write like this, 3, mu1 not equals to mu2 equals to mu3 means the population is equal to 3. If I add another one, mu4 means that our k now becomes 4. Okay, it's not 3 lah. Okay, but then for the denominator n minus k, so we know what is k already. So n is the total number of items for the whole populations combined, meaning that you need to add the number of n from sample number 1, the number of n from sample number 2, and the number of n from sample number 3. So let's say from the first population, we have 10 sample. This is 8 sample. Let's say this is 8 sample. So 10 plus 8 plus 8. Okay, we have 26. So 26 minus 8. So 26 minus 3, it will be 23. Okay, so you can see this when we do the example from the book. Okay, so for the numerator, it is k minus 1. How many population? Minus 1. N minus k for the denominator, degrees of freedom. N is the total number of samples, okay, for all the populations, for all the groups combined. And the F value is calculated as SST, okay, divided by SSE, okay. I mean, of course, SST over k minus 1. Okay, so there's a lot of formula or terms that you need to, or parts that you need to calculate before you can arrive at your F distribution value, at your calculated F value. So this is not something like you learn in chapter 8 or 9. Okay, chapter 8 or 9, if you want to calculate the t value, it's just x minus mu okay, divided by the standard error. Okay. But for the F distribution, okay, it's quite a long process because before you can get what is the calculated F value, before you can make the decision whether you want to reject or do not reject the H0 based on the critical value. So the process at arriving the F value is quite long. Okay, but once you get the idea of how to do it, it is very straightforward. Okay, so let's see how actually we do the calculations to calculate the F value. Okay, so step number 1, step number 2, step number 3, and step number 4. Okay, when step number 4 is making your decision. Okay, reject H0 if calculated F is more than what critical value. So in this example, you will see how to actually do the, okay, let's say if okay, I'm skipping to this last slide here. Okay, you can see that in this slide, the calculated F value is 8.99. So in the previous 3 slides, we are going to see how are you going to calculate, how do you arrive at 8.99? Okay, as the calculated F. The critical value here is 5.09. So how do we determine this to be 5.09 based from the table? And how do you get 8.99 from the formula that okay, that I will show you okay, how to do it. So you are given from this example 4 groups, okay, four samples, taken from 4 populations. So population number 1 is northern, population number 2 is WTA, okay, and then P and B, okay, and W, P and B. Okay, so there are 4 different populations. So from these 4 populations, you take 4 samples from the first one, 5 samples from the second one, 7 from the third one, and 6 samples from the fourth population. Okay, so there are 4 groups or 4 populations. So K will be equals to 4 lah. Okay, so K is equals to 4. Okay, how about the N? Okay, so because we know that N, we need to know what is N. So N basically is 4 plus 5 plus 7 plus 6. You add all these items together, you will get the N value. Okay, because just now, okay, to calculate the degrees of freedom for the denominator, it will be N minus K. So N in our example here is the summation of all 4 plus 5 plus 7 plus 6. Okay, that will be, you get the total minus by 4 to get the degrees of freedom for the denominator. Okay, so let's go through step by step. Okay, so step number 1, define your H0 and your H1. So in this case, okay, so I would like you just to delete this part here, okay, just to be consistent with our previous steps, okay, from chapter 7 and chapter 8, chapter 9. Okay, so step 1, you write your H1, the means are not all equal, the same sentence. Okay, for H0, because we have four populations, so you need to write based on the 4 populations. So mu n, and make sure that do not put 1, 2, 3, and 4. Okay, so the subscript should be understood based on what the population is. So N, W, P, and B, okay, is understood to be N, W, P, and B for the 4 different populations. Okay, step number 2, alpha is given as 1%. Okay, step number 3, we are going to use the F statistics because we are comparing more than 2 groups. So this is the argument. Okay, use F test, okay, or F statistics because we are comparing more than 2 groups. So this will be step number 3. Okay, step number 4. What is your decision rule? Reject H0 if computed F is greater than what value? Okay, so you need to fill in this value here. What is this value? Of course, if I skip to the last slide just now, we know that the critical F is 5.09. Okay, so this should be 5.09. But how do you read? How do you determine this value is 5.09? Okay, so the F table is divided into 2 parts, the numerator df and also the denominator df. So we know that there are 4 groups in our sample. Okay, so k minus 1 will be 3, and then the denominator will be n minus k. 22, you get 22 by summing all of this. Okay, 5 plus 6, 11. 11 plus 7, 18. 18 plus 6, 4 plus 7, 4 plus 5, sorry, 9. 9 plus 7, 16. 16 plus 6, 22 lah. Okay, so you add all these items, your K, your N will be equal to 22. So 22 minus K, K you obtain as 4. So DF for the denominator is 18. So 3 and 18 is the value that you need to refer to in the F table. So 3, and make sure that you are referring to the 1% alpha, because when you read the when you refer to your textbook, okay, in the F table, okay, you will so this is the one. Okay. Do you know where is the Anova table from the book? Okay. I'm sure there is the Anova table is somewhere in the book, but I cannot find it. Table of random numbers. Okay, B.6A. Where is B.6A? Okay, so student, okay, so it will be in your textbook on page 523, okay, 523 and 524. So you are given two tables in your textbook. One is at 5%, and the other one alpha is equal to 1%. So there is only two possible alpha that you can use in your book. Okay, either the f is equals to your alpha is equals to 1%, or your alpha is equal to 5%. So in our example here, our alpha is equal to 1% from the slide here. So alpha is 0.01. So our numerator k minus 1, 4 minus 1, 3 is, and then you refer to 3, and the denominator you get 18. So 18 and 3, the critical value is 5.09. If you refer to the table also, you should get 5.09. Okay, 18 and okay, 18, 3 and 18. So the value should be 5.09. So you can refer to the F table on page 523 and 524 for the 5% and also the 1% level of significance. Okay, so in this example, the critical value is given as 5.09 from the table when your numerator is 3 and the denominator is 18. Okay, so that will be the value that you need to insert here in step number 4. Okay, so always write the value of the critical value when you fill in the step number 4. Okay, and then step number 5, compute the F value and make a decision. Okay, so before you want to answer step number 4, you need to look at this component of the Anova table. Okay, so the Anova table, so the final value is the one that you want to get is the F value, the calculated F. So it is divided into several parts. Okay, so the first part is treatments. Okay, sum square, the source of variation. Okay, so SST, sum square treatment, SSE, sum square error. Okay, total means sum square total. Okay, so sum of square treatment, sum of square error, sum of square total. In some books, okay, the term might be slightly different. Even if you look at this textbook here, okay, if you look at our textbook and you refer to the um, show you some. Okay, if you look at this example or this exercise from your textbook on page 359, okay, on page 359, okay, in your own textbook, okay, sorry, page 358. Okay, if you look on this bottom here, question number 27, okay, the same Anova table, but the term that you see here, SST or treatments, it is replaced by between groups. Okay, and sum square error, SSE, is also known as within groups. So in some textbook or even in your past year's question, okay, you may see this term is being alternately, is being used. Okay, rather than using SST and SSE, it is replaced by between and within. So they are both referring to the same thing. Okay, whether it is between. So between is equivalent to treatment. Error is equivalent to within. Okay, so this is also from your textbook, question 27. Okay, so this is what I want to highlight, okay, before we proceed. Okay, so the second column here, okay, sum of square. So you need to get this value, SST and SSE. Okay, and then the total plus error, treatment plus error, you will get the total value. And then the degrees of freedom, okay, K minus 1, plus n minus k. K and k is eliminated, so you will get this plus this equals to n minus 1. Okay, and finally the mean square. The mean square MST is obtained by SST divided by the degrees of freedom. The same goes to the SS error. Okay. Finally, once you obtain the mean square treatment and the mean square error, okay, treatment divided by error, you will get the calculated F is the final value that you want to obtain. Okay. So you can use your calculator, online calculator, or whatever tools that you can use. Okay, this is up to you to experiment. Either you want to use manually, okay, because usually in classroom, okay, in the actual physical learning, okay, students will usually calculate this manually using the calculator. Of course, you can find ways to cut off your time, okay, using whichever functions in your calculator to speed up your calculation. Okay, so I'm just going through this formula. It's very simple and straightforward to do. Okay, so first, let's see from this example here. Okay, so we start with this raw data here, correct? You have 4 groups. Okay, and then the first thing is to calculate the mean, the individual mean for each of these items. The mean for N, W, P, and B. So 87.25, 78.2. Okay, so the mean is basically the same thing. Summation of the items divided by 4 lah. Okay, divide by 5, divide by 7. So what we want here at this stage is the mean value for each of the sample, and also what we call as the grand mean or the total mean for all the items combined. So you add all items, divide by the number of sample 22, you get the total mean or the what we call the grand mean. Okay, this is how the book defines it. Some other book will define differently, but 75.64 is the overall mean. Okay, for all the populations combined, for all the samples combined. So you get so it is noted as X bar and subscript G. Subscript G means grand lah. Okay, X bar means mean. Okay, so grand mean is equal to 75.64. So that is the first step that you need to do. First step is to calculate the mean, the individual mean, and also the total mean or the grand mean. Okay, so the next part will be to calculate the SS total and SSE. Okay, why total and SSE? If you look at the table here, okay, your table is divided into 2 parts, treatment and error. But why does it show here in this step here? Okay, but why we need to calculate total and error, not treatment? Okay, so why we do, okay, so meaning that what is shown here, calculate total and SS total and SSE, means that in your slide here, so what we so the first step is to calculate the mean. The second step is to calculate the total value here, total and error. So we do not calculate treatment directly. So because we know that total treatment plus error will be equal to total. So if you calculate total and error, so by definition, total minus error, you will get the treatment value. So the formula that we or the step that you need to do in the first step is to calculate the mean here. Okay. So the second step is to calculate total and error, not treatment. Okay, because once you obtain total and error, total minus error, you will get the treatment value, sum square treatment. Okay, so first, how do you calculate SST and SSE? Okay, it's simple and straightforward. You can see directly from the slide here. Okay, so first and foremost, we already obtained what is the grand mean, okay, from the previous step. Okay, so you can see directly here, x minus x bar grand squared. Okay, so how do you get 18.36? Okay, for the first part for northern. Okay, so how do you get 18.36? It's just basically 90. Okay, 90 minus 75.64 squared. Okay, so for example, 94 minus 75.64 equals to, and then squared, 337.09 Okay, here. So this part here, x bar, x minus, okay, actually this part is a bit misleading. So you need to remove this square here. Okay, there is no square actually in this part. So basically this is just x minus x bar grand. This is where you put the square. So 18.36 square will give you 337.09 as what I showed just now. Okay, here 337.09 is after you take the square of this value. So basically this part is just the raw value minus the grand mean. Okay, you get 18.36 and you do it for each of the following item. And then you take the square value where you will arrive at this particular box here. Okay, so here is the squared value of the raw value minus the grand mean square. Okay, and then you add all the items here. Okay, 337 plus 206 until the end, you get 649. You do the same thing for the remaining samples, and you add this. Okay, 649 plus 267, you will get 1485.10. So what this is, so what you arrive here is the sum square total, SST, or in the table here, that will be this component here, SS total. Okay, so SS total is very clear to straightforward. The raw value, okay, for example here, the raw value here, okay, 94 minus the grand mean squared. 90 minus the grand mean squared, 85 minus the grand mean squared, okay, and you repeat the process for all the items here, and you will arrive at this table here. So basically, you do not need this table here. Okay, you can just skip this part, okay, because you can do it automatically. Okay, x minus x bar grand squared, so you can get this table SST directly. Okay, so first, so now you know what is SS total. Okay, you can perform this in your scientific calculator also. Okay, you can just do it in one shot. Okay, and it depends on how you manipulate or use your calculator lah. Okay, so SS total is clear. Second part is SS error, sum square error. Okay, so how do you, so the formula is x, the raw value, minus x bar c. So what is x bar subscript c? Okay, so for example, how do you get 6.75 and then you take the square, you get 45.56. Okay, so basically, if you recall just now, the first part is you calculate the individual mean. Okay, so for example, 94 minus 94 minus 87.25. Okay, we get 6.73, correct? So this is what this value is. Okay, 6.73. 2.7. Okay, so basically what you do here is just take the raw value minus the mean for each group. Okay, so 6.75, 2.75 minus 2.25. This is all obtained by taking the 94 minus 87.25 squared. Then you will get this value here, 45.5625. Of course, some of this due to rounding error. That's why you cannot get directly the same answer. Okay, 2.75 you obtain by 90 minus 87.25, and then you take the square value, you get 7.5625. So you do the same process for each of the individual group. Okay, negative 3.2 is obtained by 75 minus 78.2. Okay, 75 minus 78.2. So you should get minus 3.2. Okay, and then you take the square value, you should get 10.24. Okay, so basically this is the difference between the SS total and SSE is just the difference between taking the difference between the raw and the grand mean for the total, and the difference between the raw and the individual mean for the SS error. Okay, SSE. Okay, so you do this, you take the sum for each of this, and you sum 110 plus 2234 until the end, you get 594.41. So once you obtain SS total and SSE, and then you can plug in into the table here. You get SS total, you know what is SSE, and then you can arrive at SS treatment. Okay, total minus error, you should get the treatment value. So 1485.10, okay, which is obtained here, 1485.10, and then 594.41 is here, 594.41. So total minus treatment, total minus error, you will get 890.69. So this value for treatment is obtained after you get total and error. And then the DF, you already know from the beginning, for the treatment is K minus 1, 4 minus 1, 3. This is N minus K, 22 minus 4, you get 18. Okay, so the mean square is 890.69 divided by 3, you get 296.9. Okay, so 890.69 divided by 3, okay, you get 296 point something. Okay, so this is the so 296.89 or 0.90 lah. Okay, so this divide by this, you get the mean square value. So sum of square divide by the degrees of freedom, you will get the mean square treatment and the mean square error. So finally, to get the F value is basically mean square treatment divided by some mean square error, 296.9 divided by 33.02, you should get 8.99. Okay, 296.9 divided by 33.02 should give you 8.99 something. Okay, so this is basically what you need to perform the calculation. So you're going to repeat the process. If you look at the textbook questions, so basically the question for ANOVA is very similar. Okay, it's almost like the same question all over again. It's just the difference whether you are doing 3 groups, sometimes you are doing 4 groups. Okay, so for example here, ANOVA okay, so if you look at some of this exercise, for example, this you have 3 groups. This is also 3 groups. Okay, sometimes you might be given up to, let's say, this is also 3 groups. Okay, this is 4 groups. So I think in terms of your syllabus, I think the most that you will get is 4 groups. Normally it's just 3 and 4 because the process is the same. But the more groups you have, the more time you need to take in order to do the calculation. But if you know how to do 3 groups, then you should know how to do 4 groups and also more than 4 groups. Okay, but of course, in the real life, you're not going to calculate this manually. This is done in your computer program. Either you can use Excel or any other software like Stata, eViews, SPSS. So this is all done automatically in the system. So why do you need to know this manually? Because when you look at this F value, so you should at least be able to appreciate what is happening behind the scene. So what is 8.99 means? So you can actually visualize the process in arriving at the answer. So for your syllabus, you need to know this, you need to calculate this manually and then refer to the F table to determine what is the critical value. Okay, so your assignment number 2 basically is just this question. Okay, you are looking at almost, I mean, I will hand in your exercise question latest by next week. Okay, so that you can concentrate on your first assignment first. But most, I think, most of the question will be on the F value here, meaning you are required to calculate the F value and you need to present your answer based on the steps that you see here. So you need to show what is the SS total table. Okay, so these two table is not needed in your solution. Okay, because this is you can just go straight to this table. Okay, the SS total and the SSE. Okay, so you need to show how you arrive at this value, SS total and SSE, and then show the Anova table and fill up the blank here. I mean, fill up the items in the Anova table and show the 4.99 here. So basically in your step number 5, okay, you need to present, you need to show this Anova table here. So this is part of your solution. Okay, so the Anova table, the value for the SST, SSE, okay, total until you arrive at the F value. Okay, this is part of the working as well. So you need to present the Anova table in step number 5 and then do the perform the so of course what you see here is quite brief. So I need to remind you again, in step number 5, you need to answer in the 3 parts. Okay, 3 parts mean whether the value is inside or outside the area of rejection. Okay, and then whether you reject or do not reject. And the third part is the meaning of your conclusion. So the meaning of the conclusion is just reject. The means are all equal. If you reject means the means are all equal. If you do not reject, the means are not all equal. So you just add the word not. Okay, if you do not reject. If you reject, you just mention the means are all equal. Okay, but here is just 2 steps, reject and the decision. So you need to mention the critical value 5 the calculated F 8.99 is bigger than or is inside the area of rejection, or you can just mention the computed F is bigger than the critical F. Therefore, we need to reject H0. So part number 3, so we conclude that the means are all equal. So in this case, because you reject, so you are going to support H0. So H0 says that the means are all equal. If you do not reject, so let's say this value is, let's say 4.1. 4.1 is less than 5.09. Means that do not reject. Okay, do not reject H0. Okay, so the means are not all equal. So add the word not lah. Okay, so this is how you are going to answer for any ANOVA questions, whether it's 3 groups or 4 groups. Okay, so I think actually we have finished our syllabus. I thought we need to spend up to next Monday, but I think the nature of this, I think of all the topics that you learn from chapter number 1 until chapter number 10, for me, this is the easiest one to do. In fact, if you were to answer this topic in your final exam questions, and if you were in UM right now, okay, sitting for your final exam, usually I would advise the student to start answering questions on ANOVA first. Meaning that the first question that you answer in your exam question will be on ANOVA, because it is usually it contributes quite a lot of mark, but it is the easiest one to do. Okay, because the question is very predictable. You are just going to be, it's usually what you see here lah. Okay, you are given the groups, and then you need to perform the hypothesis testing. Okay, so yeah, I think that's it for, okay. Before I give you out the assignment, okay, so I want you to do 1 or 2 ANOVA questions from the textbook. Okay, so let me see, maybe just 1 question should do lah. Okay, okay, so for your 1 short exercise, Okay, I need you to do this question number 12 on page berapa ni? Page 353. Okay, page 353, question number 12. So just one question. Okay, so okay, so answer A, B, C, and D and E. Okay, F no need lah. So just A, B, C, D, and E. Okay, so do these questions. So do question number 12. Okay, and I will put up the link after this. Okay, and because just one question, so please hand in the answer by bila? Okay, by tomorrow juga lah, never mind. Okay, because I think some of you are taking Principle of Economics test tomorrow morning. Tomorrow, so you might want to spend more time to do the revision. Okay, so the deadline is usual as tomorrow for tomorrow. Okay, so just one question for your chapter number 10. Okay, so I will change the due date for your assignment 1. Okay, from the 24th of June. Okay, so I will bring forward by 1 week by next week on the 17th of June. Okay, so you have one more week to do a chapter your first assignment. And then for the second assignment, I will give out by early next week. And you are also given 2 weeks to complete it. I think that is more than enough. So you should be able to submit your assignment by the last day of the semester on the 24th of June next week. Okay, so I think that's it for today.